Hello everyone, welcome to this video. My name is Amir Senahari. I'm a Google Earth Engine expert. In this video, I'm gonna give you a concrete example of global warming in the Google Earth Engine platform, a topic that is highly discussed and highly challengeable. So, let's go to the Earth Engine platform. In the first step, you should identify your region of the interest. You can choose wherever in all around the world. For example, by the drawing tools available here, I use rectangle and select the part of the USA. It doesn't matter. Location of the interest is the USA, Iran, Europe. It doesn't matter which part of the world you are going to do this. We want to show you a concrete example about the global warming to show that how the temperature changes since the 40 years ago so far. So, for example, I want to select the part of Colorado State, just like that. And then to have focus on the study area, use map.center object. Map.center object based on the geometry, the rectangle already drawn by the drawing tools available here. So, in the next step, we need air temperature data through the Earth Engine data catalog. Through the search places and datasets, go to Browse Data Catalog. After a few moments, go to Browse by Tags. Here, you can browsing your desired area, your desired dataset by different keywords. For example, the keywords can be the temperature. You can see variety of keywords, and also the keywords could be climate or something like that. For example, so far more than 90 datasets available in the Earth Engine platform so far. Go to the climate dataset or the dataset that's tagged as the climate, that's useful for climatological studies. You can see that variety of products are available here, but one of the most useful and most applicable one for the long-term time series analysis is ERA5 monthly aggregate or daily one. But I prefer to use the monthly data because to do the trend analysis using monthly or even annually helping us better to monitor the changes or track the changes to see that whether it is upward or downward. So when we want to do something like frequency analysis or something like that, daily and monthly data is very useful. Use ERA5 or go to ERA5 monthly aggregates. You can see that this data set available since 1979 to 2020, and we can have access to a big data set from the 1979 to 2020, more than 40 years data available here provided by the ECMWF. So, as you can see, spatial resolution is 27,000 meter or 27 kilometer. Variety of bands available here, but we want to use the air temperature product based on the Kelvin, and this is the average temperature at 2-meter height. So, to use this product in the code editor, just you need to type ERA5 monthly aggregate. Back to your code, through the search places and dataset, type ERA5 monthly aggregates available here. And also there are two types of the ERA5. One of them is for land, and another one is used for the land and other regions actually. For example, ocean and seas. So if you use ERA5 land monthly aggregate like this into the bands, you can see that the dataset is available since 1950 so far. This data is assimilated by the satellite and ground stations together. And you can see that temperature at 2 meters is available, 2-meter height is available, and also the spatial resolution is higher. It is around 10 kilometer or 11,000 meters. So I prefer use this product with the higher spatial resolution and also the higher temporal extent or longer temporal extent. Import it into your code just like that, and make a new variable which is array5 equals to image collection. Here we assign image collection to array5 variable. Then we need to set the filter date. So dot filter date, we need to have one start time or time start, and one time end, just like that. So as you can see here, we need to identify the time start and time end. Time start equals to 1950. This is a time start, and the time end, for example, is 2020. Just like that. It's around 7 years, and we want to monitor the air temperature or near surface air temperature for the 7 years in the Earth Engine platform. It's very important things in the Earth Engine that you can call thousands or hundreds of satellite data and do your own processing very fast, quickly, and without any challenge with a simple script. Actually, the Earth Engine is a revolutionary platform in the Earth Engine, in the remote sensing era, actually. So back to the programming. Now, for the next step, this product is monthly, but we need to convert it from the monthly to the annual format. As I mentioned earlier, if you want to see the trend of changes, would be better to convert the monthly or daily data to the annual format to see the variations more accurate and also more, really better or more concrete actually. So if you followed my video tutorial in the YouTube page, you for sure you know about the temporal collection function. The temporal collection is a function enabling us to calculate the temporal aggregations. For example, if you have daily data by the temporal collection, you can convert it to the monthly, annually, weekly, or every temporal interval that you considered for your products. So here I want to show you the function of temporal collection. For the time series analysis in the Earth Engine platform, temporal collection is very necessary to know by the Earth Engine experts because it's very helpful for the environmental monitoring and time series analysis. Temporal collection including 5 arguments starting with the input image collection, time start or start, and then number of output images expected by the users. It depends on the start time, end time, and the unit, and the interval or the time interval of each output images, and the unit that we want to get the output based on. So in the parentheses, let's go to the body of function. First, we need to make a sequence of list for the output before. Earth Engine .list.sequence started with 0 and end with the count. Earth Engine.number by count .subtract 1. Pay attention. So here we want to make a list for the output before, and this list including different rows starting from 0 to the number that we set for the count. For example, if I want to get 70 image collection as the output, I need to set the count or replace count by 70, for example. So, but as it is started from 0, we need to subtract it from 1 because if we don't, we will have 71 record in the sequence of the list or the list sequence that we are creating. For the next step, we need to set the origin date equals to, the origin date should be equal to the start. As we import the date, such as a string with a string format, we need to convert it to date format by earthengine.date function. So the start will be converted to the date format. Now we need to return the list of collections that is already created by the image collection formats. And then for each row in this collection, I need to set time start and time end and get the average. So here, to do this, make a function. Each row of the list considered as an I here, and here we make a new variable, start date equals to from origin date forward dot advance some arguments, the delta, the temporal difference between each input images that should be considered. The delta already set by the interval, the delta instead of interval instead of the delta. earthengine.number to convert the interval value as a number, and interval need to be applied on each row, and the unit keep it same. So repeat this with a little change for the end date. Another variable, end date, equals to origin date dot advance earthengine.number interval again. So with a little change, to cover one time unit after, we need to consider I as a number here dot add 1 based on the unit that is already set. So finally, the function return the input collection for a period of time that is already defined by the start date and end date, just like that. For this period of time, I want to get an average. And at the end, we need to set two important properties here. The first is the system time start, and the second one is system time end. That is necessary for the time series analysis in the Earth Engine platform. First, we need to have system time start equals to start date according to the millisecond format. We need to convert the start date from the date format to the millisecond, because the millisecond is the main format that Earth Engine uses for the time series analysis and to read the dates and related information. So next we have a set again, but this time system time end equals to end date dot millisecond, just like that. So as you can see, here we have a function, and now using this function I can convert the era 5 monthly to 7 years image collection or average of each year using the temporal function. Make a new variable, for example, annual equals to, so here temporal collection is a function helping us to do this conversion, temporal collection, but instead of the 5 input arguments, we have, for example, instead of the collection, we have era 5 data, but before that we need to select the air temperature from the era 5 bands to narrow down computations with focus on only one band, the temperature at 2-meter height. Here, the temperature band selected. Instead of the start, we have time start. So as we have 70 years from 1950 to 2020, we will have 70 1 year interval 1, and unit is year output collection. So here you can print the result to see how the code works. So here in line 21, we have a problem. Temporal collection is not defined. Maybe something wrong about the temporal collection written here and the temporal collection defined here. So if you check it, you can see that yes, there is something wrong here. Temporal collection, and now they are same. Run the code again. Code is running, and in the right side under console panel you will have 70 elements. 70 elements. For each element or each feature you will have one band. That is the average of each year, because the unit is the year. So for the next step, we want to plot the temperature changes from the 1950 to 2020. So use the print again and draw a chart. Here by the user interface chart.image.series, we can get the average of temperature for the selected region. Instead of the image collection, we have annual data, and instead of the region, we have a geometry. For the geometry, we want to aggregate the temperature to the average, to the median, to the maximum, to the minimum. You can do all of this by the reducers. For example, EarthEngine.reducer.mean. If you want to get the median, just like that, you can change it. If you want to get the max for the region of the interest, you can change like this. It depends on you. But I want to get the average temperature for the selected region. Instead of a scale, as the input data has 10,000 meter spatial resolution, here we need to set a scale as 10,000. And instead of its property, we need to have system time start, the same property I mentioned EarthEngine uses for the temporal analysis or time series analysis. So you can save your code in this step and then click on the run option. Chart is generating, and you can see that since over the last 7 years, the temperature increasing clearly. And also, if you want to get the anomaly of the changes or the percent of changes, you can do it really easily. So here you can see that, for example, here the unit of the values is Kelvin. As you can see, the temperature changes from 280 to 284 Kelvin. And if you want to convert it from Kelvin to degree Celsius, it's very simple. Just add a function to do a same calculation for each input collections. Function that considers each input images as a img and then return the img.subtract 273.15 is a constant number that uses to convert from Kelvin or conversion from Kelvin to degree Celsius. And then we need to copy all the properties to the output. Save the code again, click on run, chart is generating. And now the temperature values available with degree Celsius, the air temperature is available. And you can see that there is an increasing trend that actually started since, for example, late of 1990s. And also to know when the breakpoint is, you need to do some statistical analysis by Python programming language. But here, this is a concrete example that's showing that how the temperature raising over the last 7 years by the combination of the satellite and in situ measurements. And you can use this code for everywhere in all around the world. So now if you want to see the percentage of changes for each year compared to the long-term average, there is a simple equation or calculation in the Earth Engine platform. So we want to get the percent of changes compared to the long-term average. To do this, in the first step, we need to produce the average of air temperature for the whole of spanning time. So the average temperature mean, a new variable, equals to get the all images including under annual variable, and get the average of each pixel by dot mean function here. So now by a simple equation, the equation is like that. So the equation for percent of change is like this: the temperature of each year minus to the average and divided to the average. And if you multiply this equation to 100, you will have the percent of change for each year compared to the long-term average. So to do this, make a new variable, for example change, or any other name you prefer. So get annual image collection, use a map as a loop for calculation, and then make a new function for each input images as an img here, make a new variable as equation equals to img for each input image dot expression. Calculate this expression. The expression is same I have written before. Just copy it into the expression. But here we need to identify what the temperature is and what the mean is. So here the temperature equals to each img or each input img or each input temperature, and the mean equals to temperature average. Temperature average. And rename the output as temperature change. So the function return this equation with the properties img.property names. So now to see the changes, to see that how much temperature each year differ from the long-term average or deviates from the long-term average, you can use image.series again. Instead of image collection, this time you should import change. Instead of region, geometry. The reducer, as I mentioned, will be average, reducer that mean, scale 10,000 because of spatial resolution is, and instead of X property, you will have system time start. So when you want to show the changes, the percent of change compared to the long-term average, would be better to use the column chart. To change the chart, use set chart type and type column charts with capital format or capital letter at the first. But here annual is undefined. Here there is something wrong. Correct it. Again we have the same problem. Annual, and run the code again. The change map is creating. You can see that compared to the long-term average, for example, in 1954, where the temperature was 27% above from the long-term average. Or, for example, in 1984, the temperature was below 27% below the average temperature, below the long-term average. Or in 2012, in this region, the temperature was 46% above the long-term average. And also it's very, very helpful things to interpret how temperature changes during a time. And also these are the valuable assets provided by the Google Earth engine and remote sensing data together, and you can do very interesting thing regarding to the environmental monitoring by the Google Earth engine platform. Also, it's a good option to assess the different ideas about the global warming. You can see that since the mid 1990s, the rate of temperature obviously increases. For example, more than 10% above the long-term average, and it's showing that yes, there are very important signs of the global warming that we can see over the last 7 years. And also, if you have access to the in situ data, you can do such kind of analysis with more confidence and also with a long period of time. But when you are using with satellite data, in the best situation, you will have access to the remote sensing data since 1950 or 1960 so far. I hope you enjoyed a lot in this tutorial. I tried to make remote sensing process very easy and understandable for you. But if still something is wrong, and also if you have some questions regarding to the programming step in the Earth Engine platform, feel free to contact and put your comments here. And also I will try to help you and to understand the problems in your code. Thank you for watching us.